Hello everyone. Today we will discuss the chapter chemical reaction and equations. In this chapter we will majorly cover the equations, the types of reactions, the reason for balancing an equation and also its effect in our daily life. Chemical reaction. Chemical reaction is the process in which one or more substance reacts to form new substance. There is a basic representation of a chemical reaction which is given by a chemical equation. How to define a chemical equation or what is a chemical equation? You can write over here. It is a shorthand notation or representation of chemical reaction in terms of symbols, formulae and the ratio of number of reactants and products involved. Now, just a chemical equation is not going to serve the purpose. We need to have a balanced chemical equation. Balanced chemical equation. Now, what does this balancing term mean? Means the number of atoms on the reactant side will be equal to number of atoms on the product side. What does that mean? If I consider magnesium plus O2 which reacts to form MgO. Now if you check over here, Mg is 1, oxygen is 2, Mg here on this side is 1 and oxygen also 1. Now this equation is not balanced. How to balance this? Simply put, first see you have got oxygen 2, so write over here 2. I can't change the formula by putting 2 below it, so I can simply add 2 over here which makes magnesium 2, oxygen also 2. Now the change is that magnesium became 2 here as well. So simply make this 2, magnesium becomes 2. Now the equation is completely balanced. So this is how we balance an equation. Now let's talk about the different types of chemical reactions. First is your combination reaction. Combination reaction is basically when two elements combine to form a compound. A and B are two different elements combining to form AB is your combination reaction. For example, CaO plus H2O combines to form CaOH whole 2. So it's a combination or synthesis reaction. Next is your decomposition reaction. Decomposition is exactly opposite of combination reaction. AB breaks to form A plus B. Now depending on the mode we can differentiate them into thermal, electric and photodecomposition. Thermal means in presence of heat. Okay. Electric means electrolytic, electrolysis or electric current, and photodecomposition means in presence of light. Okay. So you can write one example for each of them, like CaCO3 on heating breaks to form CaO plus CO2, example of thermal decomposition. Next is your electrolytic decomposition of water, electrolysis, electricity will break them to form H2 and O2. And next is your photodecomposition, AgCl solid in presence of light, sunlight will break to form Ag plus Cl2. Okay. Next type is your displacement reaction. Now there are two types of displacement. See, A plus BC forms AC plus B. This is your displacement reaction. And when AB plus CD forms AC plus BD, this is your double displacement reaction. Okay. Suppose if I write an example for each one of them, Zn plus H2SO4. Product is ZnSO4 plus H2. See, only one of them got displaced. Zn combined with SO4 and H2 remains as it is. In this case, if I write for example AgNO3 and NaCl, this combines to form AgCl plus NaNO3. Just the radicals got exchanged. NO3 combined with Na and Cl combined with Ag. This is your double displacement reaction. Now, based on heat transfer, we have got two types of reaction. One is your exothermic reaction and the other is your endothermic reaction. The type of reaction in which your energy is evolved, it is known as exothermic reaction. For example, CH4 plus O2 reacts to form CO2 plus H2O and also heat energy. So, in the process, heat energy is getting evolved. So, this is a type of exothermic reaction, or any kind of burning process like burning of cracker, burning of wood, anything. All these type of reaction is going to evolve heat, huge amount of heat energy, heat and light, everything. So, that will be exothermic reaction. Respiration is a good example of exothermic reaction. On the other hand, whenever energy is absorbed, then it is your endothermic reaction. For example, CaCO3 requires heat to break and form CaO solid plus CO2 gas. So, since energy is being absorbed, it is example of endothermic reaction. Okay. Next, we will study about oxidation and reduction reactions. The simple definition of oxidation is addition of oxygen. Any reaction which is going to involve the addition of oxygen is basically your oxidation reaction. Okay. For example, if I write Fe plus O2 plus water, this is a good reaction of formation of rust, Fe2O3 dot XH2O. So, this reaction is involving your addition of oxygen. So, it is oxidation reaction. Fine. Also, the removal of hydrogen in any method or process or reaction is your oxidation reaction. Suppose you see hydrogen is being removed from the process, that is also oxidation. Oxidation reactions are undergone by reducing agent. Simply the element or the compound which carries out oxidation reaction are reducing agents. Exactly opposite. Agents means working for others. Reducing agents itself get oxidized while they reduces others. Okay, we will be talking about this thing also. For the moment, just understand what is oxidation. It is simply the addition of oxygen in any reaction. Okay, removal of hydrogen also means oxidation, also the loss of electron. Now, if you know how to count the number of electrons, then you can easily understand. But for your CBSE syllabus, this much information is enough that addition of oxygen is going to be your oxidation. And also remember this point that oxidation reactions are carried out by reducing agents, or they are known as reducing agents or reductants. I will be explaining this point again. Next is your reduction. Reduction is addition of hydrogen. You can understand this very well now. The opposite of oxidation is reduction. So, addition of hydrogen in any process, for example, Sedin or consider suppose CuO plus H2 combines to form Cu plus H2. See, in this method, both oxidation and reduction is taking place. CuO gets converted to form Cu and H2 gets converted to H2O. Now, CuO had oxygen previously, now it is having no oxygen. So, this particular compound CuO in this process is reduced. So, here CuO is reduced, fine. Now, what H2 becomes H2O. So, H2 becomes H2O. So, oxygen is added to hydrogen. So, this becomes oxidized. See, this example will help you understand all the methods. CuO becomes Cu. So, it is reduced. According to this definition, it is fair enough, like addition of hydrogen or removal of oxygen, removal of oxygen is also reduction. So see, here you had CO earlier, now you have got only Cu, so it is being reduced, fine. So basically these reactions are known as redox reactions. Actually, in reality, reduction and oxidation reaction takes place simultaneously. They occur simultaneously or they occur together in a reaction. There will be very few reactions where you will be getting only oxidation or only reduction. They in general take place together and they are known as redox reactions. So this example is a redox reaction only, where both are getting, one of them is getting oxidized and the other will get reduced, and this is always going to happen. Reduction whenever is taking place, there will be another compound which is getting oxidized. So now from here also you can find out oxidizing agent and reducing agent. See, reduction is carried out by oxidizing agent. So simply whoever is carrying out reduction is basically an oxidizing agent, and oxidation, whoever is carrying out, is a reducing agent. So the opposite is the basically name of the compound, oxidizing agent or reducing agent. In this example only, if I ask you which is the oxidizing agent and which is the reducing agent, first find out who is carrying out oxidation, who is carrying out reduction. So as you have seen here only that CuO is getting reduced. So here CuO is the oxidizing agent, and H2 is the reducing agent. That's it. This is all that is required for your information. Okay, now we will be doing some question answers. From there only you will understand what is which is the oxidizing agent or which is the reducing agent, and that is it.